Hey guys, so I was a little rusty in my last video and it went a little longer than I thought, so we'll see if I can be more time efficient now that I'm all good and warmed up. So 13.3, we're talking about permutations and combinations. A couple vocabulary terms: fundamental counting principle, permutation and factorial, combination, etc. So if you look at this problem here, it says, in chemistry class, you and your lab partner must add the samples in the test tubes to a mixture. The reactions that occur depend on the order in which you add them. How many different ways can you add the samples to the mixture? So you've got orange, red, green, and pink. So you can just list all the ways you can do it. If you want to do orange first, then we can do red, green, pink, or you can do orange, red, pink, green, or you can do orange, green, pink, red, orange, green, red, pink, or orange, so we haven't done orange, pink, green, red, orange, pink, red, green. I think that's all the ones with orange first, and then we can go on and do the same thing with red. We do red, orange, pink, green, red, orange, green, pink, and so on. But there's a lot of combinations, so you get the idea. Lots of different ways you can order them differently for the mixture. Okay, so in the solve it, you may have drawn a diagram or listed all the different possible outcomes or ways to add to the samples. Sometimes there are so many samples that listing them is not practical. So that brings us to the fundamental counting principle, which says that if event big M occurs in little m ways, and event big N occurs in little n ways, then event big M followed by event big N can occur in little m times little n ways. So for example, if there are 4 entrees and 6 drinks, you can do 6 times 4 to get 24 possible lunch specials. And then this just shows you a tree diagram of why this works. So this one's looking at pants and shirts. So you have blue jeans or black pants, and then red, green, or blue shirts. And you can see that if you have blue jeans, you have 3 possible shirts to choose from. If you have black pants, 3 possible shirts. So that gives you 6 total. You could even switch the shirt and the pants too. So you'd have like 3 trees instead of 2, but you should get the same thing either way. So that's the fundamental principle of fundamental counting principle. You just multiply your number of outcomes together. So this one says a deli offers a lunch special if you choose one from each of the following types of sandwiches, side items, and drink choices. How many possible lunch specials are there? So that tells us there are 1, 2, 3, 4, 5, 6 sandwiches times 1, 2, 3, 4 side items times 1, 2, 3, 4, 5 drinks. And if you're only choosing one, then you would get 20 times 6, 120 different combinations possible. So if we look at the problem down here, blue one, suppose that a computer generates passwords that begin with a letter followed by 2 digits, like R38. The same digit can be used more than once. How many different passwords can the computer generate? Well, you have the first digit, which is 26 letters in the alphabet, or 24? I think 26. 26 times the first digit, you have 10 options, times 10 options for the second digit, because you can repeat, so that gives you 2,600 different options, just based on the fundamental counting principle. This is also similar to a permutation. So the permutation is an arrangement of items in which the order is important. Okay, so for permutation, order is important. You can use the fundamental counting principle to find the total number of permutations. Suppose you want to find the number of ways to line up 4 friends, assuming you have 4 friends. There are 4 ways to choose the first person, 3 ways to choose the second, 2 ways to choose the third, and only 1 way to choose the last. So there are 4 times 3 times 2 times 1, which is 24 permutations or ways to arrange your friends. You can use factorial notation, which is 4 factorial, which is just 4 times 3 times 2 times 1, for any integer that is positive. N factorial is just multiplying n times all the integers before it all the way down to 1. 0 factorial is defined to be equal to 1. If we look at this next one, it says you download 8 songs on your music player. If you play the songs using the random shuffle option, how many different ways can the sequence of songs be played? So assuming that the songs don't come up again. You just do 8 ways to choose the first song, times 7, times 6, times 5, times 4, times 3, times 2, times 1, or 8 factorial ways. And I don't know what that is. I'm not going to but a lot of different ways. Okay, suppose you want 3 songs to play from the 8 songs you've downloaded. There are 8 ways to select the first song, 7 ways to choose the second song, 6 ways to choose the third song. So there are 8 times 7 times 6 ways, or 336 ways for 3 songs to play. Okay, so that's not quite a factorial because you're not going all the way down to 1. So that's what we can use permutation notation, which is this formula right here, NPR. Okay, so N is the number of items that you're choosing from, and R is the numbers that you want. So you have 8 songs, permutation is the P, and you're doing 3. So you're going to do 8 factorial over 8 minus 3 factorial, which gives you 8 factorial over 5 factorial, which comes out to 8 times 7 times 6. So because all the 5, 4s, 3s, 2s, and 1s cancel. See, these cancel, those cancel, yada, yada, yada. Okay, so I think it's really just easier to think about the space that it occupies, though. So you have 3 songs, you have 8 ways to choose the first one, 7 ways to choose the second, 6 ways to choose the third, then you don't have to worry about all this mumbo-jumbo here. So if you look at this one, it says the environmental club is electing a president, vice president, and treasurer. How many different ways can the officers be chosen from 10 members? Okay, so first you're going to choose a president, and then a vice president, and then a treasurer. So you have 10 ways to choose a president, and then 9, and then 8. So 10 times 9 times 8 gives us 720 different ways. Next one, 12 swimmers compete in a race. In how many possible ways can the swimmers finish first, second, and third? So same thing, 12 times 11 times 10. First, second, and third. In that case, order does matter because first is much different than second or third. Okay, and then we also have combinations, which are what we use when order is not important. So permutations when order does matter, like first, second, third place. Combinations when order doesn't matter, like selecting 3 fruits to make a fruit salad. Doesn't matter if you use bananas, apples, and then oranges, or oranges, apples, bananas. Those are the same combination. So combinations, the formula for this, and this one's actually used more than the formula for permutation, is NCR equals n factorial over r factorial times n minus r factorial. So a way that I remember this is your total goes on top, so n factorial. So in this case, we're doing 9 and 4, so 9 factorial on top. And on the bottom is going to be your r, which is 4 factorial. And then also you're multiplying that by whatever else you're missing to add up to 9, which in this case would be 5 factorial. So you have 9 factorial on the top, 4 and 5, those add to 9, but they're both factorials on the bottom. Okay, and it's important to note that you can't do 4 times 5 to get 20 factorial because that's just not how math works. Because 4 factorial means 4 times 3 times 2 times 1. 5 times 4 times 3 times 2 times 1 is 5 factorial. 20 factorial is going to be much bigger than both of those. So that's for a combination. So problem 4, suppose that you choose 4 books to read on summer vacation from a list of 12. How many different combinations of books are possible? So you have 12 books total, so 12 factorial, over, you're choosing 4, so 4 factorial, and 8 factorial to make a total of 12. And let's see what that gives us. Okay, so I've written them all out, basically, but if you notice, your biggest factorial on the bottom, which is going to be 8 in this case, that's always going to cancel with part of the 12 factorial, because this part right here, 8 times 7 times 6 times 5 times 4, after you get to 9, and that's actually going to go all the way down to 3 times 2 times 1 as well. That's all going to cancel with this 8 times 7 times 6, and so on at the bottom. So this biggest factorial is going to cancel with part of the 12 factorial up here, and just leave us with everything left here. So then we just try to cancel some more. So we know that 4 times 3 is 12, so those 2 can cancel with 12. I know that 2 goes into 10, and the 1 I don't really need, so I'm going to change that 10 to a 5. And now I have 9 times 11 times 5, which is something. 55 times 9. 495 different combinations of books you can read. Okay, So that's a combination. All right, next one. A service club has 8 freshmen. 5 of the freshmen are to be on the cleanup crew. Fun. Okay, for the town's annual picnic. How many different ways are there to choose the 5-member cleanup crew? So again, this is a combination because the order doesn't matter. So we're going to do out of 8, we want 5, so a remainder of 3. So actually, your 5 is going to cancel because it's the bigger factorial. So we're going to do 8 times 7 times 6 times 5 factorial over 5 factorial times 3 times 2 times 1. So this 5, 4, 3, 2 will cancel with this 5, 4, 3, 2. And then this 3, 2 will cancel with the 6. So we just have 8 times 7, which is 56 ways to choose your 5-member cleanup crew. Okay, identifying combinations and permutations. So first you just have to decide whether order is important or not. So if we look at the first one here, the college student is choosing 3 classes to take during first, second, and third semester from the 5 elective classes offered in his major. How many possible ways can the student schedule the 3 classes? Okay, so this one, it does give you a first, second, and third semester, so order is important here. So we have 3 classes he's choosing from first, second, or third semester, or out of 5 classes, sorry. So he has 5 options for the first semester. He's not going to take it again, so then he only has 4 options and 3 options. So that gives us 60 arrangements. Okay, so that one is a permutation because the order is important. Okay. B, a jury of 12 people is chosen from a pool of 35. How many different juries can be chosen? So this one, order does not matter because you just have 12 people. It doesn't matter who got picked first. So we're going to do 35. This is a combination over 12. Oops, I forgot my factorial. 12 factorial, and that would be, 23 factorial? Okay, so let's see. We know our 23 factorial is going to cancel because it's bigger. Okay, so I rewrote it because it's taking up a lot of space. So 35 factorial is on top. Notice that I stopped here at 23 and just wrote it as 23 factorial because that's just going to go down to 1 like it normally would. And then these two, 23 factorials, will cancel out. I know my 2 and my 12 will cancel and make 24. Let's see. What else could we do here? My 5 and my 4 will make 20. I don't have 20 though. 6 and 5 will make 30. So those can cancel. 9 times 3 is 27. Let's see. Do I have a 40? I don't have a 40. Okay. So then I guess we can cancel 11 and 33 and change that to 3, 10, and okay, well, let's see, 4 goes into 28 7 times. I saw the 8 and 7. Okay, and then that 7 will cancel with that 7. That's fine. Okay, and then 8 goes into 32 4 times, and 10 I can do. 5 goes into 25 5 times, 2 goes into 26 13 times. Okay, so eventually your whole denominator should cancel out, and you should get whatever's left on top, because you should have a whole number all the time. I'm not going to calculate that, but 35 times 34 times 3 times 4 times 31, and so on. So that is a combination. Okay, the last one. It says 3 pool balls are randomly chosen from a set numbered from 1 to 15. What is the probability that pool balls chosen are numbered 5, 7, and 9? Okay. So first thing you need to do is find the either the permutation or the combination to find how many possible ways there are to draw 3 pool balls. In this case, order doesn't matter because it's not saying one is drawn first, second, and third. So this one is going to be a combination. So first we want to figure out what 15, how many balls? There's 15 numbers, so 15, choose 3. Okay, 3 pools are chosen, I believe. Okay, so this will give us how many combinations of 3 balls we can get. So that's going to be 15 factorial divided by 3 factorial, 12 factorial. which basically your 12 factorials will cancel. So 15 times 14 times 13 times 12 factorial over 3 times 2 times 1 times 12 factorial. These cancel. 3 goes into 15 5 times. 2 goes into 14 7 times. So 7 times 5 times 13, which is 455. So that's going to be your denominator, 455, because that's how many total combinations there are. And then on top, we need to figure out what is the probability that you choose 5, 7, or 9. Okay, so there's only one combination of 5, 7, 9, because that's the same as 7, 5, 9. There's only one way to get that. Okay, so 1 out of 455 would be your probability. Okay, all right, and that is all for combinations and permutations. So make sure you guys do the Canvas quiz and then the Math Excel tomorrow, or whenever you choose to do it, and get some exercise, be active, do something fun, and yeah, pet a dog or something. Okay, see you guys later.